Hey guys, it's the Home Crypto Miner here. I just want to show you a very quick video because there's a lot of people within the Bitaxe community who still don't know how to run the Python benchmarking tool. They either don't know how to install Python or they don't know how to download the scripts and to run the scripts. And I think they're following quite a lot of bad advice or overcomplicated advice on how to do it. So I just want to make this very quick video on how to do it. We'll keep it short and simple. Okay, let's go. For those of you who already have Python installed, feel free to skip past this section. I will caveat this with just to make sure that you do have Python 3.11 or above installed, as a lot of the scripts seem to use it as a minimum requirement. Okay, so first of all, if you don't have Python installed, go to python.org. I'll leave the link in the description below, and you can just hit the hover over the download. You go to, in my case, Windows, but there's other versions as well for Mac OS and other platforms as well. For me, I'm just going to go to Windows. You can see as at June 2025, the latest release of Python is 3.13.4, released about a week ago. So that's a version I'm going to download and use. In my case, I'm going to download the installer, the 64-bit version, because I'm running Windows 11. So we'll just let that download. Okay, it's installed. It's downloaded, sorry. Let's just run that now. We'll get it installed. Now, we're going to hit the top option. However, I do want to check these ones down here below first, which is in particular the add Python exit to pass. So make sure that is checked, otherwise your scripts will not find the Python executable. So make sure that's selected first, and then now hit install now. And we'll let that install.
A few moments later.
Okay, setup was successful. So that took about 20-30 seconds at most. So let's just close out of that now. Okay, so once it's installed, the first thing you want to do is just double check that everything's working okay and it can find it. So let's just go down to the start command here. We're going to open up a PowerShell window on Windows. Let me just drag this over here. And we just want to type in the command Python space -- version. Okay, and you can see that it returns Python 3.13.4, which is the version we just downloaded. And the fact that it returns that means that everything's up and running fine. Okay, so now let's download the actual benchmarking script. And if you look online, there's actually quite a few of them. The most popular one is the one by MRV777, I think. Let me just open up a new tab here. I'll just paste the URL in there. So there's the link there, and I'll leave it in the bottom description as well. It's github.com, MRV777, who's the software developer, and the script is called Bitaxe Hashrate Benchmark. Now, this is a step I believe that a lot of people get wrong or overcomplicate, because I've seen people online struggling to download Microsoft Visual Code or trying to install Git and all that kind of stuff, which you can do. But to be honest with you, 99% of the people within the community here just want to download and run a script. It's only if you want to contribute back to the code base, like if you want to create a fork of this code and contribute back your own changes, then I'd recommend downloading Git and Microsoft Visual Code. But as I said, most people, you just want to download and run the script. So the quickest way to do that is go to the green button here and pull down the right arrow and just choose download zip. Boom, that's what it is. So now that's downloaded. Let's open up and have a look at it. And I'll just drag this over so you can see it. So you can see that it's just a zip file, and I want to expand that zip file to, I'll just open up another window here. I'll just expand it to my spare drive here. So I'm going to drag this over here. I'm using 7-zip, but you can use whatever tool you want to expand your zip. I'm just going to expand it to this folder here. And there it is there. So in there you can see there's a bunch of files in there. There's a README, there's a Docker file if you want to use Docker, but you don't. All we want to do, again, keeping it simple, is this Bitaxe _hashrate_benchmark script. I just want to open up the actual Python script because there's some custom config in there that you might want to look at. Most of the time you might want to just leave it, but sometimes you do want to customize it depending on what kind of power supply you're running, or if you've already modified your heatsink and fan on it. So if you scroll down to, say, line 36, you can see there's a configuration section, and this is where you can configure the overclock parameters. Now there's quite a few options here, but the three that I normally look at that you want to monitor are the max temperature of the ASIC, currently set to 66 degrees. Also the max voltage regulator temperature, currently set to 86 degrees. And also the max power voltage draw as well, wattage draw, sorry, of 40 watts. So 66 is a pretty good spot to aim for. If you like, the Bitaxes can go up to about 75 degrees before the overheat trigger kicks in. The VR temps can go over 100 degrees. However, for long-term optimum running, around the 85 to 90 degrees is optimum. And for the power wattage draw, if you're only running on your default 30 watt power supply, your 5 volt 6 amps, then 40 is too much. You want to be running that maybe down at about 24 watts if it's a 30 watt power supply, because you don't really want to exceed more than 80% of your power supply draw long term, otherwise you'll fry your power supply. So if, for example, you've purchased a Meanwell 350 watt power supply, you can crank that up to, say, 50 watts. So they're your three kind of settings that you might want to look at. And typically when you overclock your Bitaxe, depending on your ASIC lottery, you will reach your maximum overclock based on one of these ceilings being hit. Either your ASIC runs too hot, or your voltage regulator runs too hot, or you exceed your maximum power draw. So that's why when you overclock, cooling is your friend. So for now, just to keep things simple, I'm going to leave the script as is. Okay, so let's now actually run the script. So let's go back to our command window, or our PowerShell, sorry. And we're going to do an ls. And we're going to cd into the Bitaxe script folder. That's one we just downloaded and expanded. So we just do a dir again. You can see that the Bitaxe Hashrate benchmark Python script is there. Now we can just type in Python and then this name of the script. So Bitaxe _ hashrate. Now you can normally press tab to autocomplete, and then space, and then this is where you type in the IP number of your Bitaxe. So in my case, just let me double check. It is 192.168.2.49. Okay, so it's come up with a small error here, and it's because we need some more library files that we haven't downloaded yet from Python. So let's just go back to the GitHub page here, and we scroll down the README file, prereqs Python 3.11, which we've already got. Here we go. We need to install these dependencies here. So let's just run this command here first. So pip is, I think it's a circular acronym for pip, I think, installer package. So let's go back to a command window. So we're going to just paste that in. So pip install -r requirements.txt, and it should go out and fetch those extra libraries that it needs before we run the Python script. There we go, it's done. So let's just try running the Python benchmark script again. So I'm going to press cursor up and cursor up again to show my history. So Python Bitaxe hashrate benchmark.py, and then the IP number of your Bitaxe. Return. Here we go. Now it's doing it. So essentially, overclocking the Bitaxe means that you slowly increment your clock frequency of your Bitaxe until the hash rate drops off. And when it drops off, it means that you need more power, also more voltage. So then you would increase the voltage and then try hashing again. And now you would check if the hash rate is up to spec. And if it is, you then continue increasing the frequency again until the hash rate falls off again, and then you increase the voltage again. So it's a pretty long-winded process, and eventually you will hit the ceiling or the capacity of your particular Bitaxe. Now they're all different. It's what's often called the ASIC lottery. So depending on whether you've got a good ASIC or a bad ASIC, you will often hit the thermal qualities or the thermal setting of either the ASIC first. If you remember, the script was set to 66 degrees, or you might hit the thermal capacity of the voltage regulator behind the Bitaxe second, which was set to 86 degrees, or you might max out your voltage draw. The Bitaxe that we're overclocking is just a stock standard cheap AliExpress one, so I'll just show you over here. So let's just go to settings. So you can currently see that the frequency is set to 500. So normally that defaults to 525, but the benchmarking script actually starts at a 500 frequency, which we could have configured to 525, but we've left all that at default at this point in time, and the core voltage is at 1150. Okay, so let's flick back to the script. You can see some time's already passed, and you can see that what it does is it tries to run 40 iterations of tests on this current frequency of 1150 core voltage and 500 megahertz clock speed, and it will measure that against what it expects the hash rate to be. So after 40 iterations of testing here, it'll get the average hash rate here, and if it's higher than the expected hash rate for this frequency, it will increase the frequency by, I think, 25 megahertz, and it'll repeat the whole process again. So it takes about 10 minutes to run through these 40 tests each time. So it can take quite a few hours, 8 to 10 hours to run this script. Usually I'd run it overnight. So I might leave this script running for now, and we'll check back again in the morning. Oh, just one thing before I forget. If you do leave your script running overnight, make sure your PC or your laptop is not going to go to sleep. So just make sure you set it to sleep never, so that it will do the full run.
A little longer than a few minutes later.
Okay, so here we are. We've let this benchmarking script run overnight. It looks like it's finished. Let's just scroll back up to the top to see what's been going on. So back up here. So what time did we start this? We started at around 9 o'clock last night. And what time did we finish? Finished at around, was the last timestamp? 4 a.m. So what's that? About 7 hours or so? Yeah. Okay, so you can see that there's all these batches of overclocking going on here. So as I mentioned yesterday, it increments the clock speed by 25 megahertz and runs another 40 tests, and it gets the average hash rate. And if it's the hash rate is expected, then it will increase the clock frequency again by another 25. So you can see here, it was running this test at a frequency of 525 megahertz and a and a core voltage of 1150, and it was expecting hash rate of about 1000 gigahash. So it's a 1 terahash, and we did actually average that on average. And the temperature is running nice and cool. It's overnight on the ASIC and the voltage regulator, and you can see because this test passed, it actually increased the frequency from 525 up to 550, and it runs a test over and over again. And it keeps doing that until we run out of gas. So let's have a look. And when it runs out of gas, it will increase the input voltage. So 600, 625, 650, 675, 700, 725. Okay, so looks like here, what's it done? So it ran at core voltage of 1150, and a frequency of 725, and it was expecting around 1.4 gigahash, or terahash, sorry, and it only got about one terahash, so that's way below. Again, the ASIC temp was quite low, as was the voltage, but you can see here it says hash rate is low compared to what's expected. So it's going to decrease the frequency back down to 700. So from 725 back down to 700, and it's going to increase the voltage to 1170. So it jumps the input voltage up by 20, and it runs the test again. So you can see here, 1170, 700 starts running the test again at that higher input voltage. And after doing that, you can see again the expected hash rate was around 1.4 terahash, and we got exactly about that 1.4 terahash. So then it continues on. Now it increases the clock again by another 25, and it runs the test over and over again until, as I mentioned previously, one of the ceilings will max out. So we either hit the ASIC temperature of 65 degrees, I think we set it, the voltage reg temp at 86 degrees, you can see we're nowhere near that, or the wattage to be more than 40 watts draw. So let's just scroll back down and we'll see what actually caused this to max out. So here we go. So last check, core frequency 1050, input voltage 49, core voltage 1310. So it looks like it's actually hit the, wow, okay, it's hit the 40 watts. That's crazy. That's crazy, especially seeing I'm running the 30 watt El Cheapo power supply from AliExpress. So I'm surprised it actually went that high without burning out the power supply. In all honesty, I probably should have changed it to around 24 watts in the script before I ran this, but I let it go. So it's hit this, and it's hit the wattage maximum. So, and even there, you can see the ASIC is only 60 degrees, and the voltage reg was only 66 degrees. So I could have pushed this up another 5 degrees, and this up about another 20 degrees. So this tells me that if I plug this Bitaxe into a Meanwell external PSU with much more wattage, I can push this even higher. So we expected 2.142 gigahash, so 2.1 terahash, and we got about 2.1 terahash, which is fantastic for such a basic El Cheapo AliExpress BitSolo Bitaxe, running the default standard fan and running the default power supply. So that's pretty amazing. I'm really impressed with it, actually. I'll show you the screen in a second. And let's just go there now. Just get the IP number up of this Bitaxe. Let's have a look what it's doing. Hopefully it's still running. The PSU hasn't blown up, hopefully. So current hash rate 2.23. Again, that's pretty ridiculous for stock standard AliExpress. Averaging about 2 terahashes. So it's running pretty well. Okay, so power draw 38.4. Now, I don't know how that's even possible running on a 30 watt power supply. So maybe there's an electrical engineer watching here, or someone knows how this is even possible running on a 30 watt PSU without blowing up. I'd be curious to know myself. Still drawing 4.9 volts, the frequency 1000, and the voltage was around 1300, I think we said. So ASIC temp still running very cool, 61 degrees right now, and it's daytime. And the voltage reg was still running very cool as well. So as I said, I probably could squeeze out a bit more hash rate from this by pushing this to 65. I think if I plug in the Meanwell PSU, I think the next thermal ceiling I'll hit would be the ASIC temperature, because you can see that's already running at pretty much 100%, maintaining 61. So I could probably push a few more terahashes out of this if I really wanted to. So that's pretty impressive. Let's just go back to the command window here. So when you finish running the script, it kind of saves everything to a text file. There it is there. Results saved to Bitaxe Benchmark Results _ the IP, which is a text file of everything you see above here. But it also shows here as well the top 5 highest hash rate settings. So rank 1, this is what it ended up saving. So the core voltage of 1310 with a clock frequency of 1000, and we're getting about 2.2 terahashes for that. And as you can see, that's pretty much what we're getting here. Or we'll call it 2. That's still pretty damn good. So that was the highest ranking or the fastest hash rate that it achieved. And then there's a rank 2, which was surprisingly the same core voltage, but a faster frequency, which meant it kind of maxed out. So it saves the top 5 best performing hash rate configurations, and it also saves or records the top 5 most efficient settings. So this is based on your joules per terahash. So you can see here, the first rank, we were getting about 1.3 terahashes at core voltage of 1150 and frequency of 600, and at only 13.22 joules per terahash, which is pretty efficient. So again, it saves these top 5 by efficiency as well. Given the nature of Bitaxes and how low power wattage it draws, I think most of us would just want to ramp this up to as many terahashes you can get out of it if we're lottery mining. So I'll leave the video here. I hope that explains to you how to install Python and how to run the benchmarking script. Please like and subscribe for more videos.